Welcome back to the course Engineering Metrology. We are in the laboratory demonstration session here. The next instrument I have picked here is the combination set. Combination set is the combination of three major instruments. Number one, protractor head. Number two, center head. Number three is square head. So we have all the three heads here. So first we have attached the protractor head here. So the combination set has three major devices. This protractor head comprises of a rotatable turret within a stock. This is a rotatable turret which is held within a stock, and the turret has an angular scale which is graduated in degrees. This is similar to the square head, but the protractor head also can slide along the rule. It can slide, you can see here. So it can slide. Actually this is rotating here, it can slide, rule can also slide. Okay, the screw is tightened, I will loosen this screw and it can slide here. Okay. So the blade of the protractor is held firmly against the job, and the angle can be directly read from the scale. The spirit level is provided with the combination at sometimes. Here the spirit level is actually not working because we do not have spirit in it. But it is also provided to see the level whenever we need to see the leveling of the surface. The protractor can also be used to determine the deviation of angle on the job from the desired one, whatever is required. But the protractor is first set to correct angle and then locked in the position. Now then it is held to the surface of the job where the angle is made. Any deviation from the desired angle can be checked by inserting the feeler gauge. So I will just, okay, this is now locked here exactly at 0 degree. This is a locking screw. Okay. When I lock it here, I cannot move it properly. I cannot actually move it. It is now solid. Okay. So this is kind of a rule now. But if I need to measure some angle, I'll screw this. I can rotate this to the angle whatever is desired. For instance, I need to rotate it at 90 degree. Here we have the graduation. Here we have the graduation here. If I fix it to 90 degree here, okay, then I lock it. Now this angle is 90 degree and it can work as a square head. Okay. But the major use of this equipment is that we can measure the angles. For instance, I have this workpiece here. This is actually the duster. The front foam of the duster is removed here, and we have some angle. I would like to measure this angle. So what is this? If I align this to 0, this is 0 coinciding with 0. Let me see, is there any 0 error here? Okay, locking. So 0 is coinciding properly with the 0, and there is no 0 error here. Okay. So I will now put my job here, the angle for which whatever I need to measure. I will rotate this. I will rotate the combination, or the protractor of the combination head to align with the surface here. You know, it is aligned properly with the surface. It is aligned properly here. Then I lock the screw. After aligning properly, the screw is locked in this position, and I can see that this angle is exactly 61 degree. Okay, 60 degree plus 1 degree. This angle is exactly 60. It is actually about 62 degrees. Okay. So that means this angle, however, I think this is a wooden workpiece. This might be manufactured based upon the 60 degree angle. This angle might be 60 degree. Okay. This angle might be 60 degree, but because of the error in measurement or error in machining or error in manufacturing, the angle has come down to 62 degree. So there might be 2 degree deviation from the desired product that they need. But this is not as significant because this need not to be fixed anywhere. We are not fixing it. There is no fit any limits or fits. We do not have to fit it at any place. This is not a key. It can work here because we just have to hold it here. Okay. So this is the use of the protractor head. of the combination set. Okay. So, now I will remove it and attach the other set. Before going to that, I like to show you the rule, the steel rule of the combination set. You can see that we have graduation here, we have the calibration in mm and in inches here, and this is a big slot. In this slot, we have a pin here, in this, in which this key, actually this is the key here, in which this, the key is inserted. Okay, I will fix another head here. This is square head. I will see the direction of the pin. The pin is like this. The pin is like this, which is inserted here, and once the pin is inserted, it will move along the pin. Okay, the direction of pin is like this. So I'll insert it here to make sure that the pin is inserted in the slot of the screw head of the scale, sorry, it's the steel rule here. So there is a spring here to adjust the length, to adjust the location of the pin here. Okay, the screw was locked. Yeah, now the screw loosened, it is fixed properly here. So I have fixed the square head now. The square head is tightened here. So this is our square head. Okay, the square head along with the graduated rule on the combination set provides an easy way of measuring heights and depths. Okay, while the square head provides a right angle reference, so this angle is the right angle, and the rule provides the means of directly taking the readings. So we can fix the square head at any position. For instance, it is fixed at the position 15 here, close to 15. Okay, if this is my 0, I can even fix it to 0, then I can take the incremental readings. So the primary requirement is that the square head can be used only against a flat reference surface. So it is used to see the squareness, you know the definitions, flatness, squareness. So it is used to see the squareness, and the surface has to be flat. The square head is firmly held against the flat surface of the job, and rule is lowered until it touches the reference point. The rule can be locked in the position, then we can measure the distance or the length, whatever required. The range of the measure can also be extended by using attachments. We can use some instruments like square head is provided, we can use some instrument like the scriber or something to mark the distance. For instance, if this is the length of the square head, okay, I can mark something here, then I can start from here where the marking is there, I can mark here, I can keep on continuing to mark the distances where the distances are long. However, this is used to check, you know, this is the surface plate, it has to be square. So this is the requirement of the surface plate. So we can see that is this square. If we see, okay, there is no gap, we can use the feeler gauge to see if the gap is there or not. However, I think also the optical methods can also be used. If I pass the light from here or light from the bottom, if the light is not passing, that means there is no gap, and if the light is passing, that means there might be some gap. If we need to find what is the value of the gap, I can put the feeler gauge in here. Also, I can see the squareness of these surfaces, actually this plane and this plane, this surface and this surface, and it is almost square. Okay. So these are the applications of the square head. This angle in the square head is 45 degree. This angle is 45 degree. This can be used to mark anything at 45 degree. I can keep the line here and keep the component here and mark the line at 45 degree. This line is 45 degree. Okay. Now, if I keep it the other way around and try to mark another line, okay, to make it look clear in the camera. This is again 45 degree. So, this angle is 90 degree. So, any markings like here, wherever we need, this scale head is used for these purposes. Okay. Now, the next component or the part of the combination set is the center head. This is the center head. It also has a screw, this spring here, and we have the key inside. I'll insert the graduated scale here. Okay. I can lock it at any point. This angle is also 45 degree. If I need to mark this, this is actually not used to mark the angles, this is used to find the center of the circle. So, this center head attachment is used along with the stool rule to mark the center of the bar stock or any circular job. I have this, I do not have actually the exact circular job, I have this circular box here. So, it can be used, actually the diameter of job can be directly read on the graduated scale, which is useful for marking the center of the job by using a scriber. So, the V between the two blades, this V between the two blades of the center head facilitates accurate positioning of the circular job. The circular job can be positioned here. Okay. So, now this greatly improves the measurement accuracy when compared to taking readings directly using a rule held against the job. Because you know, one way is to mark the center. I try to see the center like this, or not to mark the center, to see the diameter, I try to see the diameter like this. Okay. So, actually this is from 45 from 0. Okay. But we are not sure that are we exactly at the center or not. So, this center is close, this actually the diameter is, I will mark on this side, the diameter is close to 120 mm. Okay. But the use of center gauge or center square is that it can hold the circular job in between and we can directly read while placing it like this. This would always, when I lock it here, this is always at the center. Okay. This is always at the center and I can directly read the reading here, okay, which is again actually 120 mm. So, also we can mark, suppose the center is not there, this center point, however it is here in this box. If the center point is not here, I can use the center square to mark the center. The way to do it is, I will just extend the scale here, mark a line here, I will mark a line here, okay, change the position. You can see I have marked a line here, this line if it is seen. Okay. We change the position, change this is not position, change the location here, change the location, mark another line. Now, where these two lines coincide is the center. The line that is marked from this position, the other line that is marked from the other position, when these two lines, this line and this line, this line and this line intersect, that is the center of the circle. Actually, this is the workpiece in which center was already there, because this is a plastic workpiece in which this point is here. Okay. Not workpiece, I will call it workpiece because I am measuring that is a plastic box. There are certain circular jobs in which we do not have the center. To mark the center, this is a very quick process. This is a very quick way to mark the center. So, this is the use of the combination set. We can also combine the center square with the protractor, actually not the center square, the square head and the protractor head can be used in the combination, like while we mark the square, we check the squareness of the surface, and also we can mark some angles whenever required. So, this is the application and the use of the combination set. Next instrument I will pick here is the slip gauges. Slip gauge is a set of the rectangular workpieces. You can see we have a set of rectangular workpieces here. It is a set of rectangular workpieces, rectangular pieces actually, which are made up of the hardened alloy, and the general cross section may vary from 30, actually the thickness is about 10 mm, and the cross section might be 40 into 10, 30 into 10, 50 into 10. In these cases we have different ranges of the cross sections. In general the slip gauges we will use is 10 into 40 mm. Okay. So, the name of the company that has manufactured these slip gauges is KN. So, it has 112 pieces. It is M112, which is grade 2, M112. This is the set. Okay, slip gauge set M112, which is known as grade 2. It has 112 pieces of slip gauges here. Actually, the steel is preferred material in the slip gauges because it is economical and it has some coefficient of thermal expansion, as the majority of steel components used in the production, and hardening is required to make the slip gauges resistance to wear. Slip gauges has to have very high degree of accuracy, flatness, surface finish. If I pick any of the slip gauges, you can see the surface that has to be attached to the other surface is highly accurate, is highly flat, and the surface finish is also very good. The height of the slip gauge is engraved on one of the rectangular faces. You can see the specifications here. The height of the slip gauge is given here. The value of this slip gauge is 1.1 mm. So, this is the thickness actually. You can see the thickness. This thickness is 1.1 mm, and this surface is not the significant, the thickness surface. This is not significant surface. The significant surface is the other one. It has to be highly finished. So, the length between the measuring surfaces, flatness and surface condition of the measuring faces are the most important requirements of slip gauges. Now, carbide gauge blocks are also used for their superior wear resistance and longer life. They also have low coefficient of thermal expansion because the slip gauges, when they are attached, actually this is known as ringing of the slip gauges. I will put it ringing. Ringing of the slip gauges. There are various ways. We just put one slip gauge like this, another on the perpendicular direction, then we rotate the one. Actually we hold the slip gauges, two slip gauges tight to each other, against each other, and then we try to ring them. Ring them would mean they would attach with each other. The thing is that the air between them is completely removed. Air is removed, and this is the kind of a molecular adhesion that makes them stick together. You know, this is not falling. So, there are various ways. I can just put one over there, then rotate. I can just put one slip gauge, like I can pick one like this, another one like this, then slide it. Okay, this is rotate, this is slide. There are various methods to do this, and the several slip gauges are combined together temporarily to provide an end standard of a specific length. The major role of slip gauges is that sometimes the requirement, the specific length requirement is there. The standard has to be maintained. For instance, I need to check whether my vernier caliper is reading exactly or not, okay, or if I need to have some specific length, like I will use the sine bar after this. You will see the angle that has to be measured. There is specific length, maybe toward up to the 3 places of decimal. So, that length has to be maintained. So, we need to pick some specific combination of the slip gauges to attain that specific length. Okay. So, the ringing is done using rotate and slide mode, and ringing actually is the phenomenon of adhesion of two flat surfaces. The force of adhesion is such that a set of blocks will almost serve as a single block. The grip is solid that even sometimes when it falls, it does not get separate. So, the surfaces are clean and flat, then the thin layer of film separating the blocks will also have negligible thickness. This means that stacking of multiple blocks of known dimensions will give the overall dimension with minimum error. Okay. The gap between the slip gauges, between two slip gauges, is of the order of the fourth place after the decimal. It is 0.0001. It is 1 by 10,000th. So this much gap is between, like that means if even I use 5 or 6 slip gauges or 10 slip gauges, then only the gap, the maximum gap that would be 0.0001. It would be 0.0001 into 10. If I use 10 slip gauges, this is equal to 0.001. This I am taking the upper bound. Sorry, I missed 1 0 here. 0.01. Okay. This is the upper bound. However, the gap actually is quite lower than this value. So the slip gauges that we have here is having 112 pieces. The ranges are like that. If you see on the first row, okay. So for the 112 set 112 grade, we have one slip gauge of 1.005 size. We have only one gauge of this size. Then we have from 1.001 to 1.009, and we have the gap between, I will put okay range here, range, steps, this is in mm, this is in mm, and this is number of blocks. This is 1.005, it is one block. From 1.001 to 1.009, with the gap or the step is equal to 0.001, I will get 9 blocks. You can see there we have 9 blocks. So also we have the next range from 1.01 to 1.49 with the gap of 0.01. This makes 0.1 to 49, it makes 49 pieces, and 0.5 to 24.5 gap is 0.5, so it also makes 49 pieces. So then is 25 to 100 with a gap of 25. So this makes 25, 50, 75, 100, 4 pieces. So this total is 10 and 18, 4, 12. Okay, this total is 112 only because this was M112, which is grade 2. Okay. So let me try to pick one dimension. Okay, let me see. I'll pick one dimension from the book, that is the book by Shawnee and Mahajan. Let me try to make this dimension 57.895. The way to do this is that we need to see what kind of slip gauges, what kind of gauges are available with us, and can we make this thing, number one thing. Second thing is, if we can make this thing, if we cannot make this thing, what closest value we can attain to this, the value that is given. Okay. So we have 3 places of decimal here. First we need to divide it into number of parts so as we can make it the combination. So it is 57.895. So I think it is 0.005. If I pick one of the slip gauges here, which is the first range, 1, 2, 3, 4, 5 and 6, you have 6 range sets here. So if I pick 1.005 as 1 from range 1, okay, from range 1, okay, I will pick this slip gauge 1.005. Okay, this is a slip gauge 1.05. So next I am left with a number 57.890. So what else? You know the number is 0.09. what can I do? 0.09, I can pick 1.09 here or 1.29, 1.39. The better way to do it is, if I pick 1.39, 89 minus 39 would be 50. I would be left with 57.5. So I will pick 1.39 from the range 4, from range 4. I'll pick the second slip gauge 1.39. Okay, let me try to ring them. So 1.39 is there. So then I am left with this reading 57.89 minus 1.39. It is actually 56 point now. It is 56.5. Okay, 56.5. Next I can pick 0.5 to 24.5. Next, if I pick 5.5, okay, I think I made a little mistake here. So I was thinking, why is not getting made? It is 56.89 here. So this would be 55.5. So 55.5 I can pick from the range 5. From range 5, I'll pick a slip gauge of size 5.5. So I have picked another slip gauge of range 5.5 here. Okay. Next, 55.5 minus 5.5, I am left with 50. Okay, 50 means I can pick just one, this one, the 50 exactly from range 6. I have only 4 slip gauges and I can make this height 57.895. Okay. So let us try to ring them. So the first one thing is the basic requirement for ringing is that the surface has to be very clean. Surface is almost flat. So I am trying to rub it to my skin because the skin is dry here. Then I am trying to ring them. This is 50 plus 5.5 and I have picked 1.39. Then I will pick 1.005. See, I am rubbing it. See, I have to hold it very tightly while ringing, otherwise it might, it is loosened. The reason for this might be that it is not cleaned properly. I am trying to ring it, I am trying to rub it with my skin so that it is cleaned properly. I have to clean both the surfaces, then hold it very tightly against the main block. So this is the height that we have achieved, that is 57.895. Next, I have kept the slip gauges on my surface plate. I will try to measure the distance, which was 57.895. So let me see the distance here. Okay, I lock the screws. So this distance is 57.895. With the vernier caliper, we cannot get this value. However, the value would be with the vernier caliper, the value would be close to 57 point, it should be close to 57.90 because the least count is 0.02, 0.02. This is using vernier caliper. So it cannot read 57.89 even. So this is the distance, like even the vernier calipers are available which have the sensitivity or which have the least count up to 0.001, but this vernier caliper that we are holding now is having just the least count is 0.02. So it cannot read, even it comes 57.90, we can assume that our reading is quite close. So, it is even, I think it is only 0.005 less than 57.90, so it is quite close. So, let me see the distance here in the vernier caliper. We can see that it is exactly 57.90, that is the 57th reading in the main scale division, okay, and plus we have 45th reading coinciding into 0.02, this is equal to 57.90 mm. So, this is the use of slip gauges. Slip gauges is the principle of the adhesion of the molecular forces when the air gap is completely removed. The adhesion forces, the force of adhesion holds the metal pieces together because of the very fine surface finish and flatness. Okay. Now, these slip gauges can also be used in conjunction with the sine bar. Next, I will move to that step. So, next is sine bar. This is a sine bar. The sine bar uses the principle of the ratio of the length of two sides of right angle in deriving the given angle. It is known as sine bar because we take the sine of the angle. How we do it? I will just show the calculations. Before that, let me see the components of this tool here. So, these are two end faces of sine bar, and this is perfectly square. Okay, this has to be square, and there are two rollers here. The purpose of roller is that even if I move it at any angle, this length would always remain same. This length would remain same, that center to the base length would remain same. Okay. So, there are relief holes. These relief holes are, as you know, they are, you can see that here there is some threading here. We can also put some screws and nuts if we need to hold this one. However, for the bigger sine bar, there is a big size sine bar as well. This is only 6-inch sine bar. We can even have up to 24-inch sine bar, in which the big relief holes are there to reduce the weight also. So, this is the lower surface. So, this is upper surface. So, these are setting rollers. So, it can have various dimensions. The use of the sine bar on the surface plate, you can see this setup here. We can adjust the slip gauges here. Actually, we know that this angle, if it is theta, as we know that sin theta is equal to perpendicular upon hypotenuse. So, this is the theta and this is the height here. I take the height from the center, okay, or I can, I will take this height. Okay. So, this is perpendicular and the hypotenuse is actually this value. This is height, I will better put the height here, and this is my hypotenuse. Okay. So, this can be calculated, this height can be calculated. So, while calculating this height, we can see that is the angle correct or not, that can be checked using the dial gauge here. Okay, I have made a setup here. So, we need to measure the angle of this surface. We need to measure the angle of. So, this is, I have just picked a speaker here. It has various flat surfaces, various surface at angles. I have picked this surface here. I have picked this surface. Based on this surface, I have calculated that the angle was about 18 degree and the height has come to close to 43 centimeters, 43 mm. So, this is a rough idea. I am not doing the exact calculations, but I can try to find whether this setting is correct or not. So, I have fixed my dial gauge here. Now, I will rotate this bezel to bring it close to 0. So, okay, let me think this angle is not correct. If I move it on the surface, there is the movement in the dial gauge. That means, you know, this is a big movement it is keep on continuing, it is 3 mm difference. You know, the angle is not at all correct. Okay, this is not the flat surface. The thing is that the dial gauge shouldn't be moving very much. Okay, a small movement, however, can be allowed, like depending upon the accuracy that we require, but this is not the correct height. So let me change the slip gauge setup here. So let me try to reduce it by about 3 mm. We saw that the small gauge, the small pointer moved about 3 mm in this distance. So I have to just reduce the height. So I have made another set of the slip gauges here, okay, by reducing the height somewhat, and then I will again put my dial gauge here and see if the movement is here. So the movement is less here. So at some point we can see that the dial gauge movement should be 0. Okay, this setup might take some time. Okay, we need to find the height, and we can check the angle as well. So this is the use of the sine bar. So the sine bar is based upon the principle of the sine, the perpendicular is equal to hypotenuse upon base. So for checking the angle of the small size components, a sine bar is set to approximate nominal angle on the surface plate by suitable combination of slip gauges, and it is moved over the component throughout its length. So if there is a variation in parallelism in the upper surface, the dial gauge would move and the readings wouldn't be correct. So the uses of sine bar can be it can be used for checking the constant angle error, its uses, okay, constant angle error, like this is caused by the working surface and the cylinder axis. When the working surface and the cylinder axis are not parallel, this is a constant angle error. So sine bar can be used to identify what is the value of this angle. Now another use here can be it can be used to find the progressive error, progressive angle error. So this angle is due to the cylinder center distance. So if it is in progression, the angle is changing, it is progressing, this can also be evaluated. We can also find the gauge block tolerance, if some gauge block tolerance accumulation is sometimes also the source of the progressive error. So these are certain uses of the sine bar. With this I like to close here the laboratory demonstration. Also we will continue with the demonstration on the coordinate measuring machine, and we might pick some other instrument like surface roughness tester to see the advanced, to see the, these were actually just the linear and the basic measurement that happens in the metrological lab that we have just studied. And we can also see what are the CNC machines, or what are the various digital instruments that record the information, even print the information. We will try to see them as well. So please come up with the logical questions, and we are always happy to answer you. I will try my best to answer all your queries, and we will have the quiz in the end of this week, and there's some questions, some numerical questions based upon the demonstrations, or the other questions, theoretical questions might also come in the final exam as well. So thank you.